All right, we're starting with two facts that you may not know. And if you do not embrace these things, listen today very carefully to this, because this comes up in Algebra 2. It'll follow you for a long time, not just geometry here. But if we're talking about parallel and perpendicular lines, if we're looking at the equations of these lines, parallel lines will always have the same slope. Perpendicular lines, the slopes will be opposite reciprocals of each other. So if one slope is -3/2, the opposite of a negative is a positive. The reciprocal of 3/2 is 2/3. And so notice how those two slopes are opposite reciprocals of one another. Okay, so those are the two big ideas. Parallel lines, same slope. Perpendicular lines, the slopes are opposite reciprocals. Let's take a look here. We want to find the slope of line A. Of course, if we want to find the slope of this, we can calculate with our slope formula or count 1, 2, 3 over 1. That would be a slope of 3. Find the slope of a line parallel to A. Well, that's going to be the equation of anything that has a different y-intercept than line A. So as long as your slope is 3 and you have a different y-intercept, like this would be parallel. Notice how the intercept, the y-intercept, is like a +0. As long as we don't have -3, then we're a different line that is parallel. So I'm going to put +7. But it could be anything as long as it doesn't say -3 right there. It has to have a different y-intercept, but the same slope. Find the slope of a line perpendicular to A. Well, this is going to be any line with a opposite reciprocal to the slope. The opposite of a positive is a negative. The reciprocal of 3 is 1/3. So any equation, as long as the number in front of x is the opposite reciprocal to that slope. And I'm going to do -1/3 x minus 4. It doesn't matter what you put out here. As long as the slope is an opposite reciprocal, that line's going to be perpendicular. Here it says, are these two lines parallel, perpendicular, or neither? Well, this one is not in that y equals mx plus b format. I'm going to put it in that format, and I have y equals 2x minus 3. Now I can look at the slopes. I have a 2, I have a 2. If the slopes are both 2, if they're both the same thing, these are parallel. They're not perpendicular. They're parallel because the slopes are exactly the same. Same question here. I look at these two, I can see the slope pretty quickly here, and I notice that they are reciprocals, but they're not opposite reciprocals. So in this case, they are neither. They're not exactly the same, and those slopes are not opposite reciprocals. Here it says, find a line that is parallel to y equals x plus 2 and passes through the point 3,8. Well, if it needs to be parallel, well, that means it needs to have the same slope. The slope here is 1, so my equation needs to have a slope of 1, and it needs to go through the point 3,8. If I have the slope and I have a point, I'm going to write the equation of this line using point-slope form. Point-slope form, y minus y1 equals m times x minus x1. I plug in my y-coordinate, my slope, and my x-coordinate. I simplify and solve for y. And now I have the equation of my line in slope-intercept form, which is what we want. We want to say y equals. Here, graph the line, the parallel line. our original equation here is x plus 2. So I have a y-intercept at 2. The slope is 1 up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, and so on. So that is my original line. My new line has a point at 3, 8. But also, I see my y-intercept is at 5. Same slope, up 1 over 1. Up 1 over 1, and I have that point 3, 8. And so it still goes through that point right there. 3, 8. And these are clearly parallel because they have the exact same slope. All right, similar question. We want to find the line that's perpendicular to this one, passes through the point 2, 4. Well, if it's perpendicular, my slope needs to be the opposite reciprocal, which is going to be negative 3 over 2. It needs to go through the same point, 2, 4. Well, I'm going to once again call upon my point slope form because I have a point and I have my slope. I plug all these things in. Y minus my y coordinate equals my slope, which is negative 3 over 2, times x minus my x coordinate. And I work this out. Distribute that negative 3 over 2. Got becomes a positive 3. And so my equation of my line is y equals a negative 3 over 2x plus 7. Once again, I want to graph these things. Try to give myself plenty of room here. My original one has a y-intercept at 0, and the slope is 2/3, up 2 over 3. Up 2 over 3. So that is my original one, as given in the problem. My new one has a y-intercept of 7, and the slope is negative 3 over 2, down 3 over 2, down 3 over 2. And these do intersect because they're perpendicular, but not only do they intersect, but the angle created is a right angle. That is our definition of perpendicular. So, last example here, in a race, one swimmer is swimming at a rate of 21 meters per second. Another swimmer gets a 5-meter head start and also swims at 21 meters per second. What is the equation that will model the distance y that each swimmer has gone after x seconds? Will the first swimmer ever catch up to the second? Well, they're both going to be going 21 meters per second. So after 2 seconds, they'll have gone 42 meters. After 3 seconds, they'll have gone 63 meters, and so on and so on and so on. Because one swimmer got a 5-meter head start, that's like 21x plus 5, and the other guy's just sitting over here at y equals 21x. Well, every second that goes by, this guy's going to be 5 meters ahead of the other guy. So he's never going to catch up to that guy that got that head start, because they're going the same speed. They're going they have that same slope. And so their lines are going to be parallel. They'll never meet. They'll never cross the guy.